Hi everyone, this is Deepan Chakravarti. Me and my teammates Arish Pierce and Rohit from Welltech Multitech have done a project named as Development of Static and Dynamic Obstacles Avoidance for UAV. UAV is nothing but an unmanned aerial vehicle, the programmed aerial vehicle which doesn't need any pilot for flying. In real-time flying instance, the UAV may travel across various kinds of obstacles, which is to be avoided for safe flight. So, in order to avoid these hurdles, we use max spotting sensor to detect the presence of any obstacles and passes their commands to flight controller. After identifying that obstacle, it holds at a given altitude for a given amount of time. At that same time, the obstacle is detected, and that camera, which is used as Raspberry Pi camera, which is get triggered, and image is processed using OpenCV. And the dimension of image is found by this OpenCV technologies, and these values are given back to the flight controller, and it has a flight according to this. And these obstacle dimensions can be viewed from the ground station. So main objective of our project is to detect the obstacle using ultrasonic sensor, and which is get processed into the flight controller, and after that it holds at a given altitude, and the camera is triggered by using a microprocessor or Raspberry Pi. The microprocessor is Raspberry Pi, and the process obtained image and processing the obtained image using OpenCV technology, and calculate the real-time dimensions of that obstacles, and process that information of dimensions to that flight controller, and get the information on board to the ground station. By using this real-time dimensions, we can avoid the obstacle. This is our main objective of our project. And coming to the introduction of our project and in the various advanced applications where we are using the drone, yes, drone technology has been used by defense and tech savvy consumers and various forces. And on time in time of various process on time of natural disaster. It can work for also delivery purpose without any human interface intervention in future days. Nowadays we are using Swiggy and Zomato, in which many delivery peoples are working. So this can be avoided using or replaced by using a drone, which can make a delivery in the easiest manner. So in order to provide these features, we are providing some obstacle algorithm. Coming to the view of literature review, Gay Ken and Bensby and Montenegro, yes, obstacle have done an obstacle avoidance and collision avoidance for UAV with low cost sensor, which is an IEEE paper. Low cost sensor means they have used a normal ultrasonic sensor. This ultrasonic sensor will just identify the obstacle, and it provides by using a cosine triangle law, it will avoid that obstacle and move over on, but it cannot be accurate. So we have provided we have used this technology, and we have provided an advancement of this technology. So coming to the existing methodologies, the avoidance using normal ultrasonic sensor. This was first provided by static object detection and dimension finding with HSC SR04 ultrasonic linear array. This is an array of ultrasonic sensor, which is fitted with above the server motor, which is rotating the capacity of 180 degree. And this law provided by using a cosine law. This cosine law which help to identify the dimensions of that object, not an accurate dimension. It was lagging in their accuracy. So because they are low cost sensor, this was accurate in their dimensions, not an accurate dimension they are not providing. It was providing a values ranging or error value ranging from 2 to 4 meters. So this was the limitations that avoided in this existing methodologies using ultrasonic sensor. Coming to the point of using thermal camera, the thermal camera is very low, huge in their weight and huge in their amount. So while fitting a thermal camera on behalf of the drone, and this drone weight is get increased. So the thrust, for creating a thrust, the drone need a thrust to fly. So this thrust will be take more time and power to have a flight. So this is a main disadvantage. The drone should not be more weight. So while fitting this thermal camera and lidar cameras, it has a more weight to carry on. So this is a main disadvantage which causes a more power to have a fly. So this can be avoided using our technologies. Yes, and the most effective way for the obstacle avoidance is that using lidar cameras, but lidar camera is more in their cost and it has more in their weight. So the power consumption is also largest and cost consumption is also largest. So on the other hand, we can easily implement it by using ultrasonic sensor, but their accuracy is not fine. And so by using thermal camera images, it is not so efficient at some temperatures. Accurate temperature measurements are hindered by differing emissivity and reflection from the surfaces. So it couldn't have the accuracy of plus or minus 2 accuracy, or worse for temperature measurement are not as accurate as contact methods. So it is avoided, and in order to avoid these drawbacks, we have proposed a system. This proposed system was contained with a UAV and an newly modified and particularly made sensor for flying, that is named as Matchbotics 1003 sensor. And this sensor, which is mainly made it for flight purpose, and by using Raspberry Pi cam, this sensor, which detects the obstacle, well, and it hold at a given altitude for given amount of time. At that time, this camera is get triggered and it will make a photograph, and by using this OpenCV library, the dimensions and the color shape and the shape identification have done. And this object on this by using this dimension, which is get processed into the flight controller, and this our drone will avoid it and it process through the that obstacle. This is what our technology is going to do. And coming to the block diagram of our project, we are using a PixVac flight controller. This flight controller, which was consisted with accelerometer sensor, gyrometer sensor, barometer sensor, and magnetometer sensor, and including this, it was contained with GPS for identifying the altitude, and telemetry, and Maxbotics 1003 sensor for obstacle avoidance. Okay, now coming to that power module. From this power module, it was get divided into this power is get divided into 4 ESC. This ESC will control the speed of the BLDC motor. This is used to maintain a uniform speed for all the motors. These four motors, which is get connected with the propeller, this propeller making a thrust get fly to have a flight. And this power module is get connected to Raspberry Pi onboard computer. This Raspberry Pi will do some algorithms for path planning, and also for camera triggering, and this informations will be passed through the PixVac. This is what our whole overview of our project. And coming to the point of UAV, UAV which creates thrust. What is mean by this thrust? This while the propeller run around, two propellers are in will rotate in anti-clockwise direction, and two propellers will be running on clockwise direction. While rotating the propeller, it creates a thrust. Due to this thrust, our drone will have a flight. While that thrust force is greater than that of weight of our drone, it have a flight. So So thrust is inversely proportional to, sorry, thrust force is directly proportional to the weight of the drone. Okay, coming to the point of sensor, what sensor we are using here means it is Max Robotics 1003 HRLV Max Sonar EZ0. This is a sensor which is mainly used for the purpose of flight. It has a resolution of 1 millimeter and turn Earth's reading rate and internal temperature compensation, and cost-effective solution where precision range findings are needed. And we are using 42 kilohertz ultrasonic sensor measures to measures the distance to the objects, and sensor component allows user to lower the cost of their system without sacrificing their performance. And coming to the point of camera, we are using a Raspberry Pi camera, and their both features are 5MP OmniVision's 5647 camera module, and their still picture resolution is 2592 into 1944, and the size of the camera is 20 into 25 into 9 millimeter, and weight of the camera is 3 gram, and fully compatible with many Raspberry Pi cases. And coming and the UAV working of our project is the main thing we have used in our UAV is ESC, which is used to control the speed of the drone motors. In order to maintain a uniform speed all the rotors in the drone, four rotors in the drone, we are using this ESC. ESC maintains the speed as in a higher manner, so that as fast as the propeller spins, it has a easy flight. Why? Because the propeller, as fast as the propeller spins, it creates a thrust, and this thrust makes a flight. Right? So we in which we are using a Mavling protocol. The Mavling protocol, which is used for the lightweight communication between the UAV and the ground control system, ground control stations. So it transfers the message what must be the UAV run where on the time of flight, and it also provide a control commands to that UAV. So autopilot is a software which we are using for the flight. So autopilot provides a comprehensive suite of tools, suitable tools for almost any vehicle and their application. So Mission Planner is the full featured GCS supported by autopilot. Mission Planner, which is used to provide a path planning for our drone while it is an unmanned flight, that is autopilot. So coming to the example of our autopilot path planning, this is our path planning example which are done in our campus. And OpenCV package. OpenCV package is an open source computer vision library which was consisted with a vast number of optimized algorithm, which is nearer to 2500 optimized algorithm. This 2500 optimized algorithm which is used to identify the color and shape, and what are the informations present on that picture can be extracted by you this OpenCV library. In fact, the dimensions of the object that was present in that pic can be get extracted and find using this OpenCV package. So so this is our technique. This can be anything, any cameras, that is stereo cameras or lidar cameras, any cameras we can use this OpenCV packages. So coming to the view of static obstacle avoidance, and this was the peak which was get triggered by using our Raspberry Pi cam. This was taken outside, this was taken inside our campus. So this peak as a severe image array value. So this image array value is get depicted here. So coming to the view of canny edge detection, it is nothing but it is a multi-state algorithm. Since edge detection is susceptible to some noise, this noise can be identified and reflected by using 5 into 5 Gaussian filter. So finding the intensity gradient of the the smoothened image is then filtered. The image is get filtered with some Sobel kernel in both horizontal and vertical direction to get a first derivative in horizontal direction and vertical direction. Both by these two images, we can find the edge gradient and the image density and the direction of the pixels to be followed. So now maximum subtraction, and after getting at that gradient image and the direction, the image is then fully scanned and remove any unwanted pixels. That what unwanted pixel is get removed, which may not constitute that which may not constitute to that edge. So every pixel is checked with local maximum in its neighborhood direction of gradient. So hysteresis threshold, the stages decides, this is the stage which it decide which are all the needed edges and unneeded edges, so that we have two threshold values, one is minimum value and another one is maximum value, and edges with more gradient and more than max value or some to be the edges those below that minimum value. So so the non edges or get discarded. Those who lie between these two thresholds are classified as edges or non edges. So if they are connected to the nearer sewer edge pixels, then it is a needed, so we are taking that. If not, we have to be discarded that. So this is mean by hysteresis thresholding, and this is an example where we have implemented a balloon on this scanning edge of that balloon is get detected and shown here. So next one is color identification by using HSV saturation, HSV and U and saturation and value. We are finding the color of the image, color of the respective object. Here the object is irregular shape chart, and this color is get identified, and square shape chart and this color is get identified, and the U is measured in degrees from 0 to 360, and this instance make of Sean falls between 181 to 240 degrees and magenta falls between 3101 to 360 degree, and masked image drawn with contour. The contour is nothing but it is a contour integral. By using this contour integral, the shape of the object and the size of the object can be detected. So here the masked image drawn with contour is get identified, so coming to the identification of shape. Here the shape and the size of the object, it is easily predicted by using the concept of contour. So here by using the point detection, the square image of the chart is get identified and the irregular shape with the point detection is get identified. So next one is pixel per metric concept. The pixels, by identifying the amount of pixels present in the image, their size and the dimension can be identified easily. So by using the pixel per metric concept, which is equal to object width divided by known width, here the object width is 150 pixels, so 150 px, so divided by 0.955 inches is equal to 157 pixels. So the given the obtained output is also 157 pixels. So dimension, by using this both pixels concept and contour integral, we have identified the dimensions of each chart, of square chart and the yellow chart, so that it gives a final overview and the conclusion for static obstacle avoidance. Coming to the view of dynamic obstacle avoidance, and in dynamic obstacle avoidance, the video is get captured and while such as birds or any football which is moving across the drone. So if any obstacle present on that video, this moving object is get captured, and that captured will be sent to the flight controller, and instead or control the transfer to the flight controller, and this flight controller will make a flight in the direction of right side or left side or back side according to the motion of that object which is get captured, and it moves an altitude of 1 meter in right side or left side or back side, and as mentioned by flight controller. So this what about of dynamic obstacle avoidance which we have discussed. So real time data collection, this what our real time data collection which is get screenshot from our computer, which is get om disarmed, it gets GPS satellite count value, and etc. So coming to the conclusion of our project, we have scanned two different thing. One is blue square, which is measured dimension is 41.22 into 40.33, but their actual dimension is 40 into 40, and the yellow undefined shape, which is 70.15 into 91.64 in their measured dimension, but their actual dimension is 70.9. There is a simple little change in their value, but it is not a matter because it is higher than that of we have mentioned. So our application is avoiding and the mapping and security and surveillance and construction and maintenance of training dams and all road. The future works. In future work, in order to provide and waterproofed in the rainy days and the climatic conditions, we are rainy rainwater prevent penetration, that the communication transfer is severely affected. So that we wanted to use such as a higher end processor, that means the such as mm, JSON board or etc. So the vibrations are also caused by the vehicle. So this can be avoided by using the placement OG gimbals, and high resolution such as cameras such as GoPro can be fitted here, so that the GoPro cameras, which is also auto vibrate, auto shake avoidance camera, so that the image can be in more clear. So in future, the high definition cameras and processor related at low price may be an effective solution for that above hurdles. And these are the references which we have go through. And thank you everyone.